Okay, welcome again and thank you. We are going to check some questions and answers. We are going to do a revision on the past question of the Ssce, Waec especially, which we are going to create answers to the question that are just being written, and we are picking from 2023 past questions and answers. And the subject you have to treat on is chemistry. Chemistry. Now let's look at the questions, the theory questions that was given. The number one says, what is a transition element? What is a transition element? Now, a transition element is that which has incompletely filled d orbitals. A transition element is that which has an incompletely filled d orbitals. You know, the orbitals in the electronic configurations are stationed on the number of protons. All right? But it's still the number of electrons, basically because the number of protons quantifies the number of electrons. So the number of subscripts or the number of configurations you see represents the name or the type of the element. Gives you the element's name. That means, for example, if you have 2s1, 2p2, all right? You just count the subscripts, the 1, 2, and 3 that is on top, okay? When you count them, it gives you the atomic number. It gives you the atomic number of the element. So anything you get is the number of that element in the periodic table. Anything you get is the number of that element in the periodic table. So now the transition element is telling you that it has an incompletely filled d orbitals. But IUPAC, which is the International Union of Pure and Applied Chemistry, defined transition element as the element having a d subshell that is partially filled with electrons. IUPAC defined transition element as the element having a d subshell that is partially filled with electrons. Now, the next one says, consider the electronic configuration. Consider the electron configuration of the following elements. A, they gave you 2, 8, and 6. B is 2, 8, and 2. C is 2, 8, and 1. And D is 2, 8, 8. Now, it's 2, 8, 8. They now said, state the element which forms a double charge cations. A double charge cations. A double charge cations means this is a double charge cation, 2 plus. That's a double charge cation. Now, if you see S2 plus 2 means a dication. You see the same thing as a double charge cation. All right? But in the identification of ions, we write plus 2 to identify the ion. That is a dication. But when it comes to placing it as a charge with an element, it's written as 2 plus at the superscript of that element. What do I mean? For example, I give you magnesium 2 plus. This is what I'm talking about. Instead of Mg plus 2. All right? This is basically an ion separately. This is an ion. While this becomes a dication. This becomes a double charge cation. While this is a dication. Although they are the same thing, it's just when you're identifying this as an ion separately, okay, it's plus 2, like I said. But when being identified with an element, it becomes 2 plus. Now they say consider the following elements. Okay, the element A is 286, element B is 282, element C is 281, and element D is 288. Now, first of all, we are to add the numbers they have given to us so that we know the elements first. Okay? Number one element is 2 plus 8 plus 6. That means it's giving us 16. Which element has an atomic number of 16? Or in the periodic table, which element is in number 16? That's what it means. Now, if you check, it is sulfur. Sulfur is number 16. Sulfur already is a non-metal, so it cannot form a cation. A cation is a positive ion. And we know that non-metals do not form positive ions. Okay? They form negative ions by accepting electrons. Now, the second one is 282, which is 12. That is magnesium. Magnesium. The third one is 281, which is sodium. And the fourth one is 288, which is argon. Now, in all of these, the element that forms the double charged cation is magnesium. And magnesium is written as this. This is magnesium. It forms a double charged cation. Now, the next one says, that's question 1bii. Consider the electronic configuration of the following elements. The same thing they gave to you. All right? The same thing they gave to you. The A is magnesium. The B is the A is magnesium. The B is 282. That is 2. Okay, the A is sulfur. Sorry. The B is magnesium. All right. The C is sodium, and the D is argon. The same thing they gave to you in the past question. And they say state the following element which forms a soluble trioxocarbonate 4. A soluble trioxocarbonate 4. Soluble trioxocarbonate 4 means something, when they say soluble, something that can dissolve. So they said which element can dissolve trioxocarbonate 4. The first one, the first element A there is sulfur. Sulfur. The second one there is magnesium. Magnesium. Chemical symbol Mg. The third one is sodium. Sodium is gotten from the Latin word natrum. The symbol Na is from the Latin word natrum. That's the Latin word for sodium. While the last one is argon. Ar. They said which one here forms a soluble trioxocarbonate 4? The one that forms a soluble trioxocarbonate 4 is sodium. Okay? It gives you Na reacting with CO3 will give you NaCO3. That means it is sodium trioxocarbonate. Trioxocarbonate 4. So the correct answer is sodium, or sodium trioxocarbonate, or sodium trioxocarbonate. Okay, sodium trioxocarbonate or sodium trioxocarbonate 4 are the same thing. All right, so it's Na2SCO3. So that is the correct answer, sodium trioxocarbonate 4. Now the next one says, explain briefly why there is a general increase in the first ionization energies of the element across the periodic table. Explain briefly why there is a general increase in the first ionization energies of the elements across the periodic table. Now, ionization energy is the energy required to remove an electron from an isolated atom. Now, when the energy is increasing, that means the number of electrons are increasing. All right? For example, if we have 2 electrons, I want to use electrons before I go to protons. If we have 2 electrons, for me to remove, the energy required to remove 2 electrons will be lesser than the energy for me to require 4 electrons. So as the elements, as the number as the elements are increasing, that is how the number of the ionization energy is increasing. Okay? So now, the elements are being arranged in the periodic table according to the atomic numbers. According to the atomic numbers. So, and the atomic number is the number of protons and electrons. I know that Boo will say number of protons, yes, but the number of protons and electrons when they are at rest. But just like the mass number of protons, neutrons, and electrons when they are at rest. All right? But the electrons is not at rest. So it's not calculated. They say when they are at rest, but the electrons is not what? At rest. So the atomic number becomes the number of protons alone. So the number of protons quantifies the number of electrons. Because one proton in nucleus gives us 1 electron in orbit. So and that is why the atom is electrically neutral, because it has what we call number of protons and electrons. Because 1 proton in the nucleus gives you 1 electron in orbit. So if the ionization energy is increasing, that means the number of electrons is increasing. And that means the number of protons will be increasing. So if the number of protons increases, then atomic number increases. The number of protons increases, then atomic number increases. So that means if the ionization energy is increasing, okay, now what happens is that the atomic number is increasing in the nucleus. The atomic number is increasing. So if the ionization energy is increasing, the energy required to remove an electron from an isolated atom is increasing, then ionization energy is increasing. Then that means atomic number is increasing. So the number of electrons, the number of protons is increasing. Because as the number of protons is increasing, ionization energy is increasing. The next one says, give 2 examples of aliphatic compound. Aliphatic compound. You know, from the word aliphatic, we know that these things are gotten from fat. Yes, aliphatic hydrocarbons. You know, aliphatic compounds. Okay, so these aliphatic compounds are, number 1, methane. Methane, and number 2, ethane. Methane and ethane. I think they are both from the alkane family. Methane and ethane. Methane is an aliphatic, CH subscript 4, and ethane, C2H subscript 6. These are the 2 examples of aliphatic compounds. But we can still put ethyne. All right? We can still put ethyne. Ethyne too is an aliphatic hydrocarbon, which is aliphatic compound C subscript 2, H subscript 2. Ethyne too is an aliphatic compound. Now, aliphatic compounds are organic molecules that do not contain any carbon-carbon double or triple bond. Any carbon-carbon double or triple bond. They do not have any carbon-carbon double or triple bond. That's an aliphatic compound. So let's go to the next. If you check here, methane is written like this. All right? There is no, this is methane. This is methane. There is no double. There is no double or triple bond, which is the CH subscript 4 in the context. Then the second one we said ethane, which is C subscript 2, H subscript 6. Ethane. This is the structure. C, this is H, 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 and this is H. 1, 2, 3, 4, 5, 6. So there's no double bond in them. That's a aliphatic compound, an example. So the next question is, explain briefly why alkanols are stronger bases than water. Explain briefly why alkanols are stronger bases than water. It's simple. is because the electron donating effect by the alkyl group is because the electron donating effect by the alkyl group, which is the alkoxide, ion, is stronger than the hydroxide ion. Is stronger than the hydroxide ion. It is because the electron donating effect by the alkyl group, which is the alkoxide ion, is stronger than hydroxide ions. Now, Professor Laurie is telling us that stronger the base, weaker the acid. The stronger the base, the weaker the acid. The stronger the base, the weaker the acid. So that means if the base in a solution is becoming stronger, the acid becomes weaker. The next question is, state the major raw material used in the solvary process. In a solvay process. State the major raw material used in a solvay process. Now, the raw materials used in a solvay process are 1. The raw materials used in a solvay process are 1, sodium chloride, which is NaCl, calcium carbonate, which is still known as limestone, sodium chloride, calcium carbonate, which is known as limestone, ammonia, and coke. Ammonia and coke. I repeat, sodium chloride, calcium carbonate, which is still known as limestone, ammonia, and coke. Coke is an allotrope of carbon. Now the next question says, what is geometric isomerism? What is geometric isomerism? Geometric isomerism is the existence of two compounds having the same molecular formula but differ in their structural formula. Isomerism, geometric isomerism, geometric is angles. We're going to talk about angles. Okay, this talks about the shapes of molecules. All right? So geometric isomerism is when two compounds have the same molecular formula but in different structural formula. Different structural formula. In essence, their structure is different, but they have the same molecular formula. All right? Example is methane and ethane. Methane and ethane. Example is methane and ethane. Okay? Methane have a structure that is tetrahedral. Methane has a structure that is tetrahedral. That's the shape of the molecule of methane, tetrahedral. Methane. So this is CH subscript 4. While ethane, all right, have a structure that is linear. Have a structure that is linear. So ethane has a linear shape. Ethane. C2H2. All right? Ethane. This is ethane and methane. So ethane has a structure that is linear. So the molecule of ethane is linear in shape, while the molecule of methane is tetrahedral. It's tetrahedral. So that means if you check, they have the same molecular formulas. All right? Now, when checking these isomerisms, you do not check. If you're checking it ordinarily, maybe you want to solve for molecular masses or something, this number of subscript is 5 because carbon is 1 and hydrogen is 4. Why here carbon it will be 4 because carbon is 2 and hydrogen is 2. Now, but when checking isomerisms, you check at these seen subscripts, the written subscripts. This number are the base of the elements. The written subscripts, that's what you look at. So if the written subscripts are the same, then those two compounds are isomerism. Those two compounds are isomerism. Now the existence of these two is the isomerism. Why the showcasing of them is isomer. Isomer when two compounds have the same molecular formula. Now, adding the structural formula means isomerism. Removing the structural formula means isomer. So the rate at which both of them have the same the same molecular formula, all right? The same molecular formula, 4 and 4. Same molecular formula 4 and 4 means isomer. But when they are different in their structural formula, it becomes isomerism. So geometric isomerism, for the last time, is when compounds have the same molecular formula but different structural formula. Different structural formula. Now, the next question, give a reason why water gas is better, is a better fuel than producer gas. Give a reason why water gas is a better fuel than producer gas. Give a reason why water fuel is a better fuel than producer gas. Now, it's just because the constituent of water gases, all right, are both combustible, and give higher heat than producer gas. It's because the constituents of water gas are both combustible, all right, and give higher heat than producer gas. That is the reason. They are both combustible. That means they can burn. All right? They can burn. Oxygen enhances burning. Hydrogen comes out of burning. You know, when acids react with metals, they produce hydrogen. Combustion. When you're burning something, oxygen helps in the burning. Combustion. So this is the reason why they are better than producer gases. Why producer gases do not combust. Okay? They do not combust. The next question is, define the term heat of combustion. Define the term heat of combustion. Heat of combustion, when they say combustion, combustion means burning. Combustion means burning. So the heat of burning, that's what they're telling you to define. The heat of burning, so it's defined as when 1 mole of a substance is burnt completely. When 1 mole of a substance is burnt completely. Okay, that's the heat of combustion. The next question is, state Faraday's second law of electrolysis. Say Faraday's second law of electrolysis. Electrolysis, in simple term, electro means electrons, lysis means flow. Electrolysis is simply the flow of electrons. Simply the flow of what? Electrons. Now, it states, if the same amount of electricity is passed through different electrolytes, if the same amount of electricity is passed through different electrolytes, okay, the masses of the ion deposited at the electrodes is equal in their chemical equivalence. Is equal in their chemical equivalence. If the same amount of electricity is passed, so I might say the same amount of current, it's the same thing. Same amount of electricity is passed through different electrolytes, the masses of the ions deposited at the electrode is equal to their chemical equivalent. That means the amount of current that is passed through, all right? Now, the ones that are deposited in the electrodes are just a simple solid conductors. Electrolytes are liquid conductors. That's just a simple explanation. Electrodes are solid conductors. Electrolytes are liquid conductors. Now, if current is passed through them, okay, the one that is deposited the amount, okay, the amount of ions that is deposited at the electrode will equal that of the electrode. Will equal that of the electrode. In essence, it will equal the chemical properties of the electrode. It will equal the chemical sustainability of the electrode. That means both the current that is remained of the electrode and the chemical strength of the electrode will be in equilibrium. It will not take more than. It's like aluminum and copper. All right? Now, they say if the same current pass through, for example, aluminum will be able to take what he is able to take, being a lesser good conductor than copper. A lesser good conductor than copper. Then copper will be able to take what he's supposed to take. So aluminum will not take more than what he can attain or sustain. Copper will not take more than what he can sustain. So they both will be in equilibrium. Now the next question says, calculate the amount of silver deposited when 10,920 coulombs of electricity is passed through a solution of silver salt. 1 Faraday is 96,500 coulombs mole. Calculate the amount of silver deposited when 10,920 coulombs of electricity is passed through a solution of silver salt. 1 Faraday is 96,500 coulombs. Now, they are telling you that 96,500 coulombs will liberate 1 mole of silver, 0.2 mole of silver. All right? 1 Faraday is equal to 0.1 mole of silver salt. It might be silver chloride, it might be anything. So silver salt, it might be silver chloride, it might be into silver salt. All right? So therefore, they said calculate the amount of silver deposited. All right? So it's going to be, so therefore, amount of silver to be liberated will be equals to 10,950, okay, 10,920 divided by the mole, 96,500. The answer you get becomes, this. Now let's calculate 10,920 divided by 96,500. So the answer is 0.1131606218. Okay? Let's go to 2 decimal places, will be 0.11 or 0.113 moles. That's the amount of silver that will be deposited. So the next question says, in an experiment, 20 centimeter cube of a solution containing 4 grams decimeter cube of sodium hydroxide was neutralized by 8 centimeter cube of dilute tetraozosulfate 6 acid. Write a balanced equation for the reaction. Write a balanced equation for the reaction. Write a balanced equation for the reaction. First of all, they said tetraozosulfate 6 acid. All right? and sodium hydroxide. So they say in an experiment, 20 centimeter cube of a solution containing 4 grams decimeter cube of sodium hydroxide was neutralized by 8.0 centimeter cube of dilute tetraoxosulfuric acid. Write a balanced equation. Write a balanced equation. Now, they said the tetraoxosulfuric acid and the sodium hydroxide. All right? The tetraoxosulfuric acid was, the sodium hydroxide was neutralized by the H2SO subscript 4. It was neutralized by the H2SO subscript 4. Now, what is it going to produce? They said it's going to produce, it will give us Na subscript 2, Na subscript 2, SO subscript 4, and water. SO subscript 4 and water. Now we have to balance this equation. All right? When we balance the equation, what am I going to add now that will balance the equation? If I add 2 in the hydrogen and I add 2 here, that means the equation is now balanced. So that means sodium is 2 here, sodium is 2 here. Sulfur is 1 here, sulfur is 1 here. Hydrogen is 2 here, 4 here. Hydrogen is the same thing. So this is a balanced equation for this reaction. Now the next question. In an experiment again of the same question, they say calculate the concentration of the acid in mole decimeter cube. In the same question they gave to you, they just say calculate it in mole decimeter cube. So NaOH, the concentration of NaOH is 40. Concentration of NaOH is 40. Sodium is 23. Oxygen is 16. That is 39. Hydrogen is 1. That is 40. Their molecular masses. Their molecular masses. Now, if you check in that answer we gave, they say containing 4 grams. 4 grams. So if it's 4 grams, then it's going to be 4 grams divided by the mass number. It's going to be 4 grams divided by the mass number. We have seen that NaOH is equal to what? 40. So that means it's going to be 4 grams divided by the mass number. So it's going to be equal to 4 over 40, which is equal, let's check 4 over 40. What do 4 over 40 give to us? 4 divided by 40 is 0.1. It's also 0.1 dm cube. All right? 0.1 dm cube. Now, Ca, concentration of acid, times concentration of base, will give us the number of moles of acid, of concentration of acid, and number of moles of the volume of what? Acid, which is equals to 1 over 2. Is equals to half. Now, it's going to be Ca. The Ca is how many there? 8.0 centimeter cube. That's the Ca. Times 20. Times 20.0 centimeter cube. That's the acids. All right? Equals to half. It's going to be 8. So that is the acid you got. All right? So this 8 divided by 0.1 times this is going to give you what? Half. Half. So that means, looking at this too. Now, looking at this is going to be equal to 0.1, all right, times 20. 0.1 times 20 times half times 8. 0.1 times 20 times half times 8 is going to give us 0.1 125 mole decimeter cube. So that is the concentration of acid in mole. That's the concentration of acid in mole. Now the next question, state 2 postulates of the kinetic theory of gases which real gases do not obey. State 2 postulates of the kinetic theory of gases which real gases do not obey. State 2 postulates of the kinetic theory of gases which real gases do not obey. Now, the first one says there is no force of attraction and repulsion between the molecules. There is no force of attraction or repulsion between the molecules. This is one of the things. And second one says the volume of a gas is negligible compared to the total volume of the container. The volume of a gas is negligible compared to the total volume of the container. The first one says there is no attraction or repulsion between the molecules. Between the molecules. The second one says the second one says the volume of the gas is negligible compared to the container. These are the two theories that real gases do not obey. Now I say explain briefly why real gases do not obey the postulate you stated in 2bi. Now that thing you stated, why does the real gases don't obey them? Why does the real gases don't obey them? All right? Why don't it obey them? It does not obey them. For example, a real gas are gases that occupy space. Okay, are gases that occupy space and their molecules have interaction. And their molecules have interaction. Example is oxygen, carbon monoxide, carbon dioxide, and so on, hydrogen, and so on. Now, say, why don't they obey? Now, looking at that, you will know that real gases are liquefied by cooling. So the volume is not negligible. Because as the gases are liquefied by cooling, that means the volume is increasing. So if I have a gas occupying 20 centimeter cube, for example, and I liquefy it, the volume is going to increase because liquids occupy more volume than gases. So that means that the volume of a gas is negligible is not applicable in that particular area. And the second one is because they can occur. They can occur and actually occupy space. They can occur and actually occupy a space. Now the next question is, okay, looking at this, what is the name of this compound? Now looking at the following compound, you will see that OH is placed at the end of the compound. That's to tell you that it is considered an alcohol group. Considered an alkanol group. Now, what ferments? What produces the alcohol that you're seeing? OH is alcohol. What produces the alcohol is carbohydrate. The fermentation of carbohydrate produces alcohol. Now, which class of carbohydrate? You know, when you check, you see that the glucose is the simplest form of carbohydrate. That means the glucose comes from a family of monosaccharide. And the monosaccharide becomes the simplest unit of carbohydrate. All right? Simplest unit of carbohydrate. And the glucose becomes simplest form of carbohydrate. So if you check, if carbohydrate will be fermented, then that means it must first change to glucose before it can be fermented. Because starch changes to sugar, sugar changes to what? Glucose. So for carbohydrate to be fermented, it has passed through the process of starch to sugar, then to what? Glucose. So that means this compound is considered glucose. Now, name two structural isomers. Now, the structural isomers are coming from the same group. So which group does these compounds belong to? This glucose belongs to monosaccharide. So that means the isomer are compounds of the same molecular formula. The same molecular formula. Now, if glucose comes from monosaccharide family, then that means That means the isomers must come from the monosaccharide family for them to have similar molecular formula. And monosaccharides are glucose, fructose, and galactose. Glucose, fructose, and galactose. So that means the two structural isomers of the compound will be glucose, will be fructose and galactose. Fructose and galactose. Now, instead, the chemical process of preparation of the compound from starch is hydrolysis. Hydrolysis is the process of using water to break down molecules. So if the glucose is changing to carbohydrate, if the fermentation of carbohydrate is alcohol, that means alcohol is water. Alcohol is liquid. Okay, so the process passed through is a water process. That means the process is called hydrolysis. Like I said, hydrolysis is the process of using water to break down molecules. Next question says, consider the following compound. Write a chemical equation for the steps involved in the process of 2-II. Write a chemical equation for the step involved for the process of 2-II. You look at the structure first. The C6, 1, 2, 3, 4, 5, 6. Then the H is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, the H is 10. And the O is how many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The O is what? 5. The O is 5. All right? Now, we said the process is hydrolysis. The process of this is hydrolysis. So it's going to be plus N or plus just H2 subscript. So it is water that is used to break it down. Water that is used to what? Break it down. So the water breaking it down will give you C. All right? It will give you C12, H12, and O what? 11. This is the first process. This is the first chemical equation. All right, this is the first chemical equation. This is the first chemical equation. Now, the second chemical equation is using the water. Using this equation, C12, H12, O11, what is it going to produce? All right? What is it going to produce? Now, this thing is with water. It's going to give you the glucose. These are the two steps the two chemical equations for the two steps into II. Now, the next question, consider the following. Name 2 enzymes involved in the process of 2C. The 2 enzymes involved in the process of 2C are maltase and diastase. Maltase and diastase. You know that an enzyme is a biological catalyst. It's a biological catalyst or is a chemical catalyst. But basically it's a biological catalyst. Okay, it's proteinous in nature. But the 2 enzymes that are used in this are maltase and diastase. Let's go ahead and say, explain briefly the term structural isomerism. Structural isomerism. Now, structural isomerism is the existence of 2 compounds with the same molecular formula, but differ in their structural formula and that has different physical and chemical properties. Structural isomerism is they have the same molecular formula, but they are different in their structural formula and different physical and chemical properties. Now, this talks about how the arrangement of atoms, how they are being arranged is different. All right, while geometric is talking about the arrangement with the carbon. This one is talking about the arrangement with atoms, how their atomic arrangement differ. Now, since the atomic arrangement is different, that means they are going to be different in both chemical and physical properties. So this is structural isomerism. The next one says, a compound contains this, of this, and this. A compound contains 52.2% carbon, 13.1% hydrogen, and oxygen only. The vapor density of the compound is 23, determined in the empirical formula. The vapor density of the compound is 23, determined in the empirical formula. Now, vapor density is times 2 of the number. So if they say find vapor density of a substance, for example, you take the substance, you take the molecular formula and divide by 2. So the vapor density is already given, then that means the vapor density came times 2. So if a vapor density, for example, if a vapor density is 23, for example, is 23, that's the vapor density given to you. 23, that's the vapor density given to you. That means what they did was 23, was a substance, was the molecular formula divided by 2 that gave you 23. So getting that will be 23 times 2, which is 46. So that means the actual atomic mass number is 46. That's the actual atomic mass number. 46 was the actual atomic mass number. All right? Or the molecular mass number. Why? That's why the vapor density is 23. So this is simple empirical formula. All right? Simple empirical formula. They said a compound contains 52.2% carbon, 13.1% hydrogen, and oxygen only. And oxygen only. Now, the first step of empirical formula is you're changing the percentage to grams. Changing the percentage to grams is still the same as the percentage you got. What do I mean? Since carbon is 52.2, that percent is going to be 52.2 grams. Simple. There is no magical changing. Okay? 0.2 grams. There's no magical changing. All right? So, let's start solving. The first one says change percentage to grams. So, carbon is 52.2%. All right? Hydrogen is what? Hydrogen is how many? 13.1. 13.1. And oxygen. And oxygen alone. Oxygen is 6. Oxygen is 6. But in solving empirical formulas, what we work with, so oxygen is 8, sorry. Oxygen is 8, but solving empirical formulas, what we work with, we work with their molar masses. We work with their molar masses. All right? So therefore, this oxygen will be what? 16. Since the percentage is not given, then it's going to be 16. Percentage is going to be 16 because that is the molar mass of oxygen. Now, the second step says divide by their molar masses. Divide by their molar masses. Carbon's molar masses is 12, hydrogen is 1, and oxygen is what? 16. So that means what we are going to have, carbon, they say divide by their molar masses. So carbon will be 52.2 divided by 12. Hydrogen will be 13.1 divided by 1. And oxygen will be 16 divided by 16. Divide by the molar masses. So therefore, carbon is equal to, let's see, 52.2 divided by 12 is 4.35. Carbon is 4.35. Hydrogen is 13.1. And oxygen is 1. And oxygen is 1. So now, this is the next step. Now, the next step says, this is step 1. This is step 1. This is step 2. Now, the next step says, take the smallest answer and divide through by it. take the smallest answer and divide through again by it. What do I mean? Now the smallest answer here is 1. That's the smallest answer. That means you're dividing all these substances, all these molar masses by 1 again. That's the smallest answer, 1. So let's take that, which is step 3. Step 3 is equals to carbon is equals to 4.35 divided by 1, which is equals to 4.35. Hydrogen is equals to 13.1, which is equals to 13.1 divided by 1. Oxygen is 1 divided by 1, which is equals to 1. Now they say the answer you get becomes their subscripts. The answer you get becomes their subscript. That means the carbon subscript is 4.35. Hydrogen subscript is 13.1. Oxygen subscript is 1. But take note, if your answer is in decimal, convert to the nearest whole number before you make it the subscript. If your answer is in decimal, convert to the nearest whole number before you make it a subscript. That means the nearest whole number for carbon is 4, because 3, that is after the decimal, is not up to 1. So carbon will be equals to 4. Hydrogen is equals to, if you check 1.1 is not up to 5, so it cannot be approximated to as 1. So hydrogen will be 13. Then oxygen will be 1. So the subscripts now will be C subscript 4, A subscript 13, O. That is the molecular formula of this compound. That is the molecular formula of this compound. And the next question says, a compound contains this again. Vapor density of the compound is 23. Determine the molecular formula. Determine the molecular formula. Determine the molecular formula. Now let's see. Determine the molecular formula. Okay, they gave you the vapor density. So vapor density is 2 times the number. Vapor density is 2 times the number. So 2 times Vd is equals to 46. That means you go back to the normal vapor density. Okay? So it's going to be C subscript 2, H subscript 6, O. Will be equals to what? 46. So therefore, it will be 12 times, because 2 times 6 is 12. So it will be 12 times 2, which is 24. 12 times 2 is 24. So it will be 46 divided 24. It's equals to 1.916. 1.916, which is equals to 1.9, or it can approximate it to what? 2. So the molecular formula will be C2HO. That's the molecular formula. C2HO. Let's go to the next one. A compound reacts with sodium metal to produce hydrogen gas, and when warmed with acidified potassium manganese, gives a solution which turns from purple to colorless. It also forms a sweet-smelling liquid when heated with ethanoic acid in the presence of concentrated tetraoxosulfuric acid or sulfuric acid. Name the functional group present in the compound. Now, looking at this question, you will see that the potassium tetraoxomanganese was in an aqueous solution. An aqueous solution is a solution where the solvent is water. That means it was put into water. Okay? So the solution turns from purple to what? Colorless. That means the color of the compound potassium tetraoxomanganese is purple. Now, when we react with water, it became colorless. That means in this context, water became a base. Because water can act as an acid and a base, and that process is called autoionization, where water acts as an acid and a base. Now, water acts as an acid when it donates proton. So this particular thing, this one becomes a base. So, and they say it also forms a sweet-smelling liquid when heated with ethanoic acid in the presence of concentrated sulfuric acid. Now, ethanoic acid is a weak acid. Therefore, it's going to be, water will now be a strong base. Water will now be a strong base. According to Brosted-Lowry, he said, stronger base, the stronger the base, the weaker the acid. So that means if ethanoic acid is the weak acid, because after the reaction, they now said it was reacted when heated with ethanoic acid in the presence of this, in the presence of sulfuric acid. So therefore, water now is now acting as a base. The first time it acted as an acid. All right? So now when heated with an acid, it's now acting as what? A base. So since the ethanoic acid is a weak acid, therefore, that water will become a strong base. So the functional group present in that compound is hydroxyl. 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 The next question is, the compound reacts with sodium metal to produce hydrogen. When gas and when warmed with acidified, this gives, okay, the same question. They just say draw the structural formula of the compound. H is 1, C is 12, and O is 16. Just draw the structural formula of the compound. Now they're trying to draw the structural formula of the hydroxide, because that's the hydroxide that was formed. So therefore, the structural formula is simple. C, yes, C, okay, O, H. All right? That's the first structure. So the H, the carbon bonds with hydrogen. This is the structure, the structural formula that is formed. That's the structural formula that is formed. The next question is, outline the chemical equations for the production of ethanol from cooked cassava. From cooked cassava. Okay? From cooked cassava. So, the structural formula will be two into C6 from cooked cassava, H10O5 bracket, cooked cassava, N plus. That's number of moles. That N, that number of moles, is not really necessary. So, but you can still put the number of moles if you want. Let me change the marker. So this is a diastase. This is diastase. All right? That is a diastase. Now it will give you the number of moles C to H. This is the first structure. Now, coming down again, O11, all right? We said it's hydrolysis. This is maltase. This is maltase. Bracket, all right? It gives you glucose. It gives you what? Glucose and glucose. Now, if you check, hydrolysis has taken place in this area. Because when this reacts with water, the maltase, when the maltase reacts with water, it breaks down, it ferments, okay? It decomposes and gives you what? Glucose and glucose. So the first one gave glucose, the second one gave glucose. Why? Because water is being used, okay, as hydrolysis. Water is being used to break down the molecules, to decompose the molecules. all right? And to decompose cassava is starch, all right? So when water is used to break down to smaller molecules, the simplest form of carbohydrate is glucose. So when the diastase reacts with water, they say chemical equation with production of ethanol. All right, the ethanol comes to the fermentation. So before it's going to ferment, like I said, it's going to start from starch, which is the cassava, to sugar, simple sugar, sucrose. Then it now goes to glucose. It is the glucose that ferments and gives you the ethanol or the alcohol. So looking at this equation, you see that the diastase, all right, pass through the process of hydrolysis using water when to break down to give you. Now, it breaks down to what? Maltase. This gives you what? Maltase. This gives you maltase. Now, the maltase is now broken again by still water, and it gives you what? Glucose. So, therefore, the starch, all right, the starch, okay, has been broken down to what? The monosaccharide starch has been broken down to disaccharide. The polysaccharide, sorry, which is a starch, has been broken down to what? Disaccharide. Now, the disaccharide, what has still broken down to what? Monosaccharide. Now, it is from this area that the ethanol will be formed. From this fermentation process that the ethanol will be what? Formed. Right? So, now, coming down to this, it will give you this. Okay? We produce, this will produce to H subscript 5 OH, all right, plus 2C subscript 2O. Now, this is a diastase, okay, the cooked cassava. That's a diastase, cooked cassava. Water is being used. Water is being used to break it down. This N represents the number of moles. If you like, you put. If you don't like, you leave. It's the same thing. Okay, this number of moles. The number of moles of this. Okay, this is the number of moles of diastase. That's what it means. So now water is being used to break down. I told you hydrolysis is whereby water is used in breaking down the molecules or breaking down complex molecules to simpler what? Molecules. The hydrolysis. So now hydrolysis, water. Now for ethanol to come out, ethanol is alcohol. Water must be used in breaking them down. Hydrolysis must occur. Now water is used in breaking down the polysaccharide diastase. Now, when water is being used to break it down, it broke it down to what? Maltase, which is a disaccharide. Water again broke the disaccharide maltase to glucose, which is the simplest form of carbohydrate. Now, the simplest form of carbohydrate broke down into zymase. Okay, gave us zymase and carbohydrate. Now, the zymase becomes the ethanol. This becomes ethanol. All right? This now is the ethanol. Now, the decomposition of carbohydrate gives us carbon dioxide and water. So when the fermentation has occurred, all right, the fermentation has occurred. Now, water is no longer there to break down again because you have got into the ethanol, which is the alcohol. That is fermentation. Now, after fermentation, decomposition occurs. So the decomposition produces carbon dioxide and water. So when carbohydrate is decomposed, it brings carbon dioxide and water. When fermented, it gives you alcohol. So the next one, explain briefly why a piece of aluminum does not react with water. Why a piece of aluminum does not react with water. It is the same thing why it is being used to prevent corrosion. It's almost the same thing. All right, so it's because it creates an oxide film that does not react to water. That's all. Because it creates an oxide film that does not react to what? Water. Now, for corrosion, it creates an oxide film that prevents corrosion. That's just the thing. So that is why aluminum does not react with water. Because it creates an oxide film that is resistant to water, that does not react with water. The next question says, how can a pure sample of aluminum chloride crystal be prepared from aluminum? How can it be prepared from aluminum? Now, first of all, you add dilute hydrochloric acid to excess aluminum filter. You add dilute hydrochloric acid to excess aluminum filter. Now, if you check the aluminum chloride crystal, you know that chlorine is involved. All right? So that means, you know, when aluminum is reacted with acids, or when metals react with acid, they send out hydrogen. They send out hydrogen. Now, when you mix the hydrochloric acid, okay, when you add dilute hydrochloric acid to the excess aluminum, all right, you remove the excess metal. When you add it, there are some metals that will not dissolve. All right, you remove the excess metal. Since the aluminum is now more than the hydrochloric acid, you remove the excess metal and keep it in a warm place. That means you filter and get the excess metal. You now keep it in a warm place. When you keep it in a warm place, it is not going to evaporate because of the heat. So that means add dilute hydrochloric acid to excess aluminum, all right? Then remove excess metal and keep in a warm place. The evaporated filtrate to print crystallization. The evaporation will filtrate to print crystallization, then leave it in the sun. Then you leave it in the sun. So that is how to prepare sample of aluminum chloride crystal from aluminum. The next one is describe how water can be separated from aqueous copper sulfate. From aqueous copper sulfate. Now, aqueous copper sulfate, that means it's just a liquid-liquid separation technique. Okay? Aqueous copper sulfate, that means the copper sulfate is now in water. It's now dissolved in water. So that means you're separating the liquid from the solid. So the flask is connected to a condenser and the solution is heated. Okay? When solution is heated, the water evaporates. Simple. The flask is connected to a condenser and the solution is heated. When the solution is heated, the water will evaporate and change to liquid in the condenser. Now, a condenser is another process that converts vapor to liquid. Converts vapor to what? Liquid. Now, that process is called condensation. When vapor is converted to liquid, it's called condensation. So, when you put the flask is connected, when you connect the flask to the condenser, you heat the solution. That means you heat the copper sulfate aqueous solution. Then when you heat it, evaporation means the water will evaporate and the condenser will make it to turn to what? Liquid. The next question is, starting with calcium chloride, describe briefly how a solid sample of calcium triiosocarbonate 4 can be prepared in the laboratory. In the laboratory. Now, water. All right? Water is added to calcium chloride to form a solution, first of all. Water is added to calcium chloride to form a solution. Now, the sodium and the carbon monoxide is added to the solution to precipitate. To precipitate. Then the calcium carbon monoxide, which is filtered, will be washed and dried. Water is added to calcium chloride to form a solution. The sodium and the carbon monoxide is added to the solution to precipitate. Then the calcium carbon monoxide which is filtered will be washed and dried. The next one says, with relevant equation, outline the procedure for the purification of impure copper. Outline the solution for the purification They say, with relevant equation, outline the procedure for the purification of impure copper. Now, it's just simple. The impure copper acts as an anode, and the pure copper acts as a cathode. What do I mean? Since the impure copper, since it is impure, impure means it has lost its efficiency, it has lost its strength. So therefore, it becomes a poor conductor now. While the pure copper becomes a good conductor. So that means you're making the impure conductor a pure conductor. So you're purifying the impure copper to a pure copper. So that means the anode, that is the impure. All right? The anode, that's the impure copper. The anode that is the impure will definitely give out Cu2 plus and 2E minus. That is it. Then in the cathode, all right, it's now become pure. It will be Cu2 plus. All right? Then since it will be what? Aqueous. Okay, you put it in water, okay, now it's going to give you 2E minus plus Cu. This is aqueous. This is the equation. Copper reacts with concentrated triazonitrate 5 acid with a balanced chemical equation for the reaction. Write a balanced chemical equation for the reaction. A balanced chemical equation for the reaction. Now, they say write a balanced chemical equation for the reaction, okay? Cu solid. Copper reacts with concentrated triazonitrate 5 acid. Okay, the balanced equation will be as HNO subscript 3. Okay? What does it give? Okay, it gives Cu bracket NO3. Copper reacts with concentrated triazonitrate 5 acid. Write a balanced equation for that. So it will be plus NO subscript 2 and water, liquid. This is the reaction. Quite all right. All right? This is the reaction. Quite all right. This is aqueous. Like I said, an aqueous solution is a solution where the solvent is water. This nitrate is gas. Now, balancing of the equation will give me this. Cu solid plus 4 HNO subscript 3 will give me CuNO bracket 3 aqueous. All right, plus NO2 NO subscript 2 plus 2 H2O liquid gas. This is a balanced equation for the question given to you. Because this is the equation. This is the question they gave to you. Copper dioxide concentrated this. This is concentrated. All right, it's concentrated. Now it's going to produce this and this. Triazonitrate. Because the copper now becomes a metal. So when metal reacts with acid, they release oxygen. So the oxygen being released based on the copper being reacted with water and salt. Because the acid reacting produces hydrogen. So the hydrogen becomes salt and water. Because when acid reacts, the acid becomes a donor. The acid becomes a donor. So that means both of them joining will give you gas and liquid. Gas and liquid. Because the gas, when metals react with acid, or when acid reacts with metal, they bring out the gas. They bring out the gas. So this is a balanced equation for that. This is the question. This is the question. This is the question. Like I said. Now this is the balanced equation. This is the balanced equation. This is the question that they asked. This is the balanced equation. The next one, copper reacts with concentrated acid. State what will be observed in the reaction. State what will be observed in the reaction. Now, the reaction, first of all, we have metal dissolving, because the metal will dissolve in the acid. All right? So when the metal dissolves in the acid, you experience gas bubbles. All right? Because as the metal is dissolving, since it's an acid, there's bound to be gas bubbles. Amount of heat, a high amount of heat is needed. Then it changes to reddish-brown gas. Then it turns to a blue solution. The first one is said the metal will dissolve. Then gas bubbles will be experienced. Then it changes to a reddish-brown gas. Then changes to a blue solution. This one says copper reacts with concentrated thioxonitrate 5 acid. State why the copper is oxidized. State why the copper is oxidized. You know, when copper reacts, all right, with an acid, it becomes weaker. Okay? It becomes weaker. Why? Because the acid melts the metal. So it becomes weaker. And when the acid melts the metal, they produce gas, hydrogen gas. So therefore, the copper loses its strength. So it loses electrons. Remember, the copper is a metal. The copper is a metal. All right? So when copper reacts with concentrated triazonitrate 5 acid, why the copper is oxidized is because it loses what? Electron. Now, we know that oxidation is the gain of electrons. That's when it comes to oxygen. But in hydrogen, oxidation is the loss of electrons. So when copper reacts with concentrated triazonitrate 5 acid, they produce hydrogen. When metals react with acid, they produce what? Hydrogen gas. Hydrogen gas is emitted. So that means in that hydrogen, copper will be oxidized by losing electrons. Because oxidation in relation to hydrogen is the loss of electrons. Is the loss of electrons. So that means copper emitting hydrogen reacting with acid must have to lose electrons. So because copper lost what? Electrons. The next one is the copper reacts with concentrated triazonitrate 5 acid again. And excess of copper is added to 25.0 centimeter cube of 16.0 mole decimeter cube of the tetraozonitrate 5 acid. Calculate the volume of the gas formed at STP. H is 1, N is 14, O is 16, and copper is 63. Molar volume of gas at STP is 22.4 decimeter cube. So the mole of NHO3, okay, mole of acid, all right, is 0.25 times 16. The mole of the acid, let's calculate. It's a very simple thing. All those, this 23, that 23, they give to you, is irrelevant. Okay, the mole of acid, the mole of the acid is, they said a copper is added to 0.25, have it? 25.0, sorry. 25.0 centimeter cube. Okay, excess copper is added to 25.0 centimeter cube of 16.0 mole of this. So, mole of acid, so the mole of acid or the mole of HNO3 is equals to 25.0 times 16.0. Okay? Times 16.0. Because they say copper reacts with concentrated triazonitrate 5 acid and excess of copper is added to 25.0. And excess of copper is added to 25 of 16.0 mole. So that means the main mole of copper is 16. They now added 25. So what will be the mole? It will be 25 times 16. Are you know what I'm saying? They say copper reacts with concentrated triazonitrate 5 acid and excess of copper is added to 25.0 of this. So that means the main mole is 16 and 25 was what? Added to it. So that means it will be 25 times 16. So 25 times 16 is equal to 400. 400. Now, they say the molar volume of the gas at STP. So therefore, the molar volume of the gas at STP of a gas at STP. Now, converting this to molar volume, because you have gotten this as cm cube. When you convert to decimeter cube, it will be 0.4 because it's divided by what? 1,000. Because they say molar volume at gas at STP is 22.4 dm decimeter watt cube. So therefore, what you're looking at is the decimeter cube because it was added to 25 of 16. So the main volume is 16 decimeter cube. So you have gotten the answer as 400. Now you have to convert it to the decimeter cube, which is what? 0.4. Which is 0.4. Now, you have gotten your 0.4 as the main mole. You've got your 0.4 as the main mole. All right? Now, they say copper reacts with this. To calculate the volume of the gas at STP, H is 1, N is 14, and O is what? 16. So getting this, since there are two gases, all right, excess copper is added to tetraoxo, to concentrated triazonitrate. So there are two. The copper is added to it. So the 0.4, therefore excess will be equal to 0.4 divided by 2. So I said the excess gas is equals to 0.4 over 2, which is equal to 0.2. Now you've gotten it as 0.2. So now your main answer will now be volume at STP will be equal to 0.2 times 22.4, which is equals to 0.2 times 22.4. Why? The 22.4 is the standard temperature. So at every given point in time, this is the standard temperature. That's the standard temperature. All right? So when you get the main volume you have gotten, you now times it by the standard temperature. So 0.2 times 22.4 is equals to 4.48 decimeter cube. That is the answer. Now, let me start again. I said mole of HNO subscript 3, which is triazocarbonate 5, is 25 times 16. Why? They say the excess copper is added to 25 centimeter cube of 16 mole. That means in the 16 mole, excess copper was only added to 25 of it. Okay, in the 16 mole decimeter cube, excess copper was added to 25 centimeter cube. to 25 centimeter cube. That means excess copper was added to 0.025 centimeter cube. That's what a decimeter cube, that's what it means. If you convert 25 centimeter cube to, if you convert 25 centimeter cube to decimeter cube, you get 0.025 decimeter cube. So in decimeter cube, it is 0.025. But in centimeter, it is 25. So in the 16 decimeter cube, they just removed 25 and added copper. So for me to get the mole, I must have to add that 25 of copper that they added alone times the 16. It will give me 400 centimeter cube. So I change the 400 centimeter cube to decimeter cube, which is 400 divided by 1000. It gave us 0.4 decimeter cube. Changing it. All right? So now the SS will be divided by 2. Because copper was added, so it is SS. The SS that you get now is 0.2. That's the SS. That's the amount of the SS copper that was added to 25. You know, I guess you're following. The copper that was added, we don't know the amount. Okay? So we have to find the amount of copper that was added. So this is the amount of copper that was added. Now, you now do the amount of copper that was what? Added. So the volume at STP will be this amount that was added times the standard temperature and pressure, which is 22.4, which is 4.48 decimeter cube. So the next question, pure HNO subscript 3, which is pure HNO subscript 3 is a colorless liquid. When exposed to air, it turns yellowish brown in color. Explain briefly this observation. It is the same trioxocarbonate 4. Okay? Trioxocarbonate 4. So pure trioxocarbonate 4 solution. Now, they say what? They say you should explain briefly the observation. Now, what did you observe? All right? When the pure trioxocarbonate liquid is exposed to air, it turns yellowish brown in color. What did you observe? 1, it undergoes decomposition. Okay? It undergoes decomposition. And 2, the salt dissolved. And 2, it dissolved. It undergoes decomposition, and 2, it what? Dissolved. That's what it means. The next one says, write a balanced equation for laboratory preparation of hydrogen trioxonitrate 5 acid. Write a balanced equation for the preparation of hydrogen trioxonitrate 5 acid. Write a balanced equation for hydrogen trioxonitrate 5 acid. So it will be 2KNO3. Balanced equation for hydrogen trioxonitrate 5 acid, okay, plus H subscript 2SO4 will produce K2SO4 and 2HNO subscript 3. All right, so NaNO3, H2SO subscript 4 will produce Na. Okay, this with this Na HSO4 plus HNO subscript 3. So this is the balanced equation for that. Okay, reaction of hydrogen trioxonitrate 5 acid. This is hydrogen trioxonitrate 5 acid. So this is the balance equation for this. This is balanced with this, and this is balanced with this. So the next is describe how iron and aluminum react with each other of the following substances. Dilute this. Now, iron will react easily. Iron react easily to form iron tetraoxosulfate. To form iron tetraoxosulfate 6. To form iron tetraoxosulfate 6. So iron will definitely dissolve easily. It's going to dissolve because metals do dissolve in acids. And I said they produce oxygen. But aluminum, like I said, forms an oxide film that is resistant to these things. So in aluminum, there is no reaction for aluminum. It does not react. But iron reacts to form iron sulfide. But for aluminum, there is no reaction. Describe how iron and aluminum react with each other. The following: dilute this. The same thing. Okay? The same thing. Iron, when iron dissolves to liberate hydrogen. Iron dissolves to liberate what? Hydrogen. But in aluminum, there's no reaction. Iron dissolves to liberate hydrogen. When a metal, iron is a metal, when a metal reacts with an acid, it liberates hydrogen. It emits hydrogen. Now, that's one of the characteristics of metals. So, but aluminum is a brittle metal. All right? It creates an oxide film. So, it does not react with water. It does not react with liquids. It creates an oxide film. It does not react with what? Liquids. So, since it does not react with liquids, it does not face corrosion. For example, using aluminum for roofing, okay, it does not rust, it does not corrode. Since aluminum does not corrode, it's because it creates an oxide film that is resistant to water, resistant to corrosion. Remember, for corrosion to occur, the metal must have to face water. That metal does not have the tendency to resist water. But aluminum has that tendency to resist liquids. So it does not dissolve in acids because it creates an oxide film that is resistant to this. Okay, so the iron dissolved and liberated hydrogen, but aluminum, no reaction. Write an equation for the burning of sulfur in air. The burning of sulfur in air. You know, that means the combustion of sulfur. That's what it means. You know, when burning reacts with oxygen. Burning reacts with oxygen. And carbon is emitted. Now, burning is like, okay, let me define a fuel and use that to explain. A fuel is any substance that enhances burning with the aid of oxygen. So that means what enhances burning is oxygen. So for sulfur to be burnt in air, that means sulfur must react with oxygen. Because anything that burns reacts with oxygen. Oxygen enhances burning. That's one of the characteristics of oxygen. It enhances burning and emits carbon as a result. So therefore, write the equation for the burning of sulfur in air. So sulfur will react with oxygen gas to create sulfur oxide. Sulfur 2 oxide. That's all. Sulfur reacts with oxygen gas because the oxygen gas enhances burning. So sulfur reacts with oxygen gas to create a sulfur oxide. That is the equation. Name the catalyst used in the contact process. Name the catalyst used in the contact process. The catalysts used in contact processes are vanadium, and 2, oxidized planetized asbestos. Oxidized planetized asbestos. asbestos, vanadium unoxidized planetized asbestos, planetized asbestos. These are the catalysts used in contact process. In the contact process, why is an excess of air used? Why is an excess of air used? Why is an excess of air used? It's simple. It's just to favor the formation of more products. Just to favor the formation of more products. Sulfur trioxo. Sulfur. This is the formation. Okay? This is the more product that is created due to a contact process. Due to a contact process. Sulfur trioxo. I said it is used because to favor the formation of more product. And this is the product that is formed. So the next one says, why is it necessary to cool the catalyst used in 5BII? Why is it necessary to cool the catalyst used in 5BII? Why is it necessary to cool it? Why is it necessary to cool it? That the catalyst used, like we said, is vanadium and oxidized planetized asbestos. Now, why is it necessary to cool it? Okay, it's necessary to cool it because, one, all right, it will enhance the formation of a new product. Because it will enhance the formation of more products. So when being cooled, the products are formed easily when being cooled. That is the reason. This SO3 is formed easily when being cooled. So they say, give a reason. The next question, number 5BV. Give a reason why the air used in the contact process needs to be as clean as possible. Needs to be as clean as possible. You know, when there's a contact process, the air needs to be as clean as possible so as to allow a free combustion. So as to allow a free combustion, free burning. That's why the air should be clean as possible. The next one says, state two reasons why sulfur oxide should not be discharged into the atmosphere. Yes, it should not be discharged into the atmosphere. Remember, every oxide, when gases are burnt into air, they react with oxygen. Therefore, they form acidic rain. They form acidic rain. And when the acidic rain comes, it damages living things. It damages living things. So at least these are two reasons why the sulfur oxide should not be discharged into the atmosphere. It causes acidic rain, same as nitrogen oxide. Any gas that is being burnt into air causes acidic rain and damages living things. So therefore, if they ask you, why would any gas oxide that is burnt into air not react, all right, should not be discharged into the atmosphere, rather, you just tell them the two reasons are it causes acidic rain and two, it damages living things. So the next one is state the reagents and conditions used in the laboratory preparation of chlorine. The reagents are manganese 4 oxide and concentrated hydrochloric acid. The reagents are manganese 4 oxide and concentrated hydrochloric acid. This is manganese 4 oxide and concentrated hydrochloric acid. The reagents are manganese 4 oxide and concentrated hydrochloric acid. These are the two reagents that are and conditions used in the laboratory preparation of what? Chlorine. Now the conditions are heating, bleaching, room temperature, heating, bleaching, and room temperature. Though heat is not required, all right, but a little heating, bleaching, okay? It must be in room temperature. It must be in room temperature. So heating or low heat, room temperature, and bleaching. These are the conditions. Okay, why the reagents are manganese 4 oxide and concentrated hydrochloric acid. The reagents are manganese 4 oxide and concentrated hydrochloric acid. And the conditions are heating, all right, bleaching, and room temperature. The next one is state 2 uses of chlorine. Yes, uses of chlorine. Chlorine is used as bleaching, okay? And that bleaching is called hypochlorite. Chlorine is used as bleaching. Is used as a disinfectant. Is used as an antiseptic, okay? It's used as chlorine, it's used as a bleaching, disinfectant, and antiseptic, okay? These two, you can take one. It's still used as insecticide. It's used as a germicide. It's used as an insecticide, germicide, disinfectant, antiseptic, bleaching, and so on and so forth. So these are the uses of what? Chlorine. They say, name the drying agents for each of the following gases. Hydrogen. Hydrogen fuse is calcium. Name the drying agents for each of the following gases. Number 1 says hydrogen. Hydrogen, drying agent for it is fused calcium. Fused calcium chloride. Drying agent for hydrogen is fused calcium chloride and concentrated tetraoxosulfate 6 acid or sulfuric acid. Fused calcium chloride and concentrated tetraoxosulfate 6 acid. These are the drying agents for hydrogen. The next one is sulfur 4 oxide. Sulfur 4 oxide is sulfur 4 oxide and anhydrous calcium chloride. Anhydrous calcium chloride. Anhydrous calcium chloride. Then for ammonia is silica gel and quicklime. Calcium chloride, silica gel, and quicklime. Ammonia is calcium chloride, silica gel, and quicklime. State the components of the following. Bronze. Bronze is copper and tin. Bronze is copper and tin. Bronze is an alloy made of copper and tin. Then brass is still an alloy made of copper and zinc. Brass is copper and zinc. So I think this is the end of this revision class. Thank you very much.